Hi, welcome back to PSLE Math and MLGS. Now today we are going to look at a PSLE concept on volume, and it's going to be a very easy lesson and not very hard to understand. So let's look at the first part of the lesson and how do we find the volume of each solid in cubic units. So what is a cubic unit? It is cubes. All right, you have to count the cubes, and every cube that you see is a cubic unit. So if you look at the first solid figure, now how many cubes make up this solid figure? Now I will count layer by layer. So let's look at the bottom layer. How many cubes are there? You will find that there are 4 cubes that are exposed, right? 4 cubes without anything on them, and then there are there are 2 cubes sitting on 2 cubes below. So if you are unable to see those cubes, they are hiding, right? Those cubes that you can't see, then how do you know whether they are there? You look at the cubes that are sitting on them. So if there are cubes sitting on them, it means that will be how many cubes at the bottom. So if there are 2 cubes sitting on top, then there must be 2 cubes at the bottom. And then again, there are 2 cubes sitting on top, and so there'll be another 2 cubes at the bottom. So the first level or the first layer has 8 cubes altogether. And then on the second level, it's very easy to see. You can see that there are 4 cubes, right? 1, 2, 3, and 4. So you have 4 cubes sitting on top. So how many cubes make up this solid figure? There are 12 unit cubes or 12 cubic units. Alright, so let's look at the next one. And again, how many cubes or how many cubic units is the solid figure? So you count those cubes that are exposed, right? These are the cubes with nothing sitting on top. So you have 8 cubes, 9, 10, 11, and there's 1 cube that's on top. So it has to be sitting on something below. So that will be 12 cubes. So the first level, alright, the first layer, there are 12 cubes at the bottom. And of course, the top layer, there's only 1 cube on top. So altogether, there will be 13, right? 13 cubes that make up the solid figure. So when you count the cubes, you do not randomly count one by one. You have to count from the first level, then the second level, and so on. And those cubes that you can't see, how do you know they are there? You look for the cubes that are sitting on top. They must be sitting on something below. Okay, so let's look at the next one, a bit more complicated to count the cubes. So how many cubes make up this solid figure? So you look for those cubes that you can see very clearly, very obviously. So there's 1 cube, there's a second cube, and then there's a third, and there's a fourth, and there's a 5, all right, there's a 5th cube, and then there's a 6, and then there's something behind that you can't see. So how do we know that there's something behind? Because the top cube must be sitting on something right below, right? So on the first level, how many cubes are there on the first level? So you start counting 1, 2, 3, 4, 5, 6, 7. So there'll be 7 cubes on the first level. So those cubes that you can't see, that's hiding inside, you look for the cubes that are sitting on top. And how many cubes that are sitting on top will be how many cubes that are sitting below. Alright, then how about the second floor? Second layer, you have 1, 2, and 3. So these are the cubes that you can see very obviously, very clearly. And then again, there's 1 cube that you can't see. And how do you know how many cubes there are that you can't see? You look at the cube that's sitting on top. So it must be sitting on something below, right? On 1 cube that's below. So on the second floor, there will be 4 cubes, right? 4 cubes on the second layer. Now, the top layer, there is only 1 cube. So in total, how many cubes are there? There will be 12 cubic units. Alright, this figure is made of 12 cubic units. Alright, so that is how you count the cubes one by one, right? Layer by layer. Alright, how about the next one? Now, same thing, the first level, how many cubes can you see? I can see 3 cubes that are exposed. And then how about the cubes that I can't see? Then you just look at how many cubes they are sitting on top. You have 1, 2, 3, 4, 5, and 6. So they must be sitting on 6 cubes that are right below. So on the first level, there are 9 cubes on the first level. Alright, how about the second level, second layer? Now the second layer, again, if there are 6 cubes on top, they must be sitting on 6 cubes below. So the second layer has 6 cubes. And of course, the top layer, you can see the 6 cubes that are sitting on top. So altogether, how many cubes are there? There will be a total of 21 cubes or 21 cubic units. So this is how you count the cubes for any given solid figure. Okay, let's go to the next one. Okay, so let's move on to the second part of the lesson. And how do you draw the front view, the side view, and the top view? Now, the front view, you have to follow the arrow, the direction of the arrow. So which means that you have to draw facing this way. And if you face this way, you can see that there are 3 cubes standing. So you will have to draw the outline of the 3 cubes that are standing. And then there are 2 cubes on the bottom right. Okay, 2 cubes on the bottom right. So you need to darken the lines that you are drawing. And after darkening the lines, after you draw the outline of the front view, what I will always do is I will do some shading so that it's clearer. Alright, so that the teacher can see your front view clearly and give you the marks easily. Alright, how about the side view? Now the side view, you have to face this direction. So which means that you have to stand at the side of the right side of the solid figure and face the figure. And how many cubes will you see on the right side? You will see 3 cubes that are standing in a column. So you draw a column and cut into 3 boxes. So what you are doing is you are drawing the outline of the side view. And of course I will do some shading. Okay, and that is your side view. Now your top view is from above. So you have to look down from above. And when you look down from above, you will see 3 cubes, right, in a row. So you have to draw a row and cut into 3 boxes. And then again, you do some shading. Okay, but don't color, all right? Don't color totally black because we don't want to waste too much time on the shading. All right, the next one, how about the top view? Now, same thing, let's draw the front view. So how do you draw the front view? So again, if you look at the front view, you will see 3 squares, right? 3 squares. So the first 2 square, right? The 2 squares is on the left side, and there's 1 square on the bottom right. So that is your front view, and of course you have to do some shading again. And then your side view is when you look from the right side, and when you look from the right side, you will see again 3 squares. But the 2 squares this time, the 2 squares is now on the right. Okay, this is your 2 squares on the right, and there's a 1 square on the bottom left. So that is how your side view looks like. And again, draw some, do some shading. Okay, now top view, if you look from above, you will see 2 squares on the left and 2 squares on the right if you look from above. So which means that when you draw the top view, it will be something like this, and you cut into four smaller boxes, right? That is your top view. And again, you have to do some shading. So you can see that it's quite easy to draw the front view, side view, and the top view. Okay, let's look at one more example. Now, how do you draw the front view? By facing this way. So you can see that 3 squares, then 2, and then 1. So you have 3, 2, 1. So you draw the outline of 3 squares, and then the outline of 2 squares, and then 1 square. So 3, 2, 1. And again, the shading. Alright, let's look at the side view. Now sometimes your side view can also be from the left side. It's not always on the right side. So your arrow could be pointing pointing this way as well. But for this question, alright, this question is pointing from the right side. So when you look from the right side, you will see 3 squares in a column. So you draw a column, okay, draw a column and cut into 3 boxes, and then the shading. Okay, alright, now how about the top view? Top view, you look down from above and you will see 3 squares in a row, and you draw 3 squares in a row, and that is how you draw your top view. And that's how you draw the top view, front view, and the side view. So you can see that it's actually very easy to solve, to score marks for these kind of questions. Okay, let's go to the next one. Okay, so now we come to how do we find the volume of a cube. Now what is a cube? A cube is like a dice that has equal sides, right? Equal sides. So not only the cube has all equal sides, it means that every side are the same, right? Not only the cube has all sides are equal, the faces are also square faces. So the cube has all square faces. Alright, so how do we find the length of one edge or one side? So if you are given the volume of a cube, then how do you find one side of the cube? Then you will need to find the cubic roots. Okay, the cubic roots of the volume. So if the volume is 1, then what is the cubic root of 1? Which is still 1. What does that mean? It means that since the cube has all equal side, it means that a number times the same number is equal to the volume. So what number is that? That will be 1 times 1 times 1. So the cubic root of 1 cm cube, alright, the cubic root of 1 is 1. Okay, so every side is 1 cm. And that's how you get the volume, 1 times 1 times 1, right? Okay, now, and by the way, how do you find the volume of a cube? Now, to find the volume of a cube, right, which you will see later on, now to find the volume of a cube, now there is a formula that you need to remember, which is length times breadth, but because the cube has all equal sides, so we don't call breadth, we call it length. Length times height. Okay, length times height. And that is how you find the volume of a cube. Alright, why we don't say length times breadth? Now, every time you have length times breadth, it means that you have a longer side for the length and the breadth is the shorter side. Right? So when you have length times breadth, that is the area of a rectangle. So if you want to find the volume of a cuboid, which is a rectangular block, right? A cube is a square block, right? Square block. A cuboid is a rectangular block. So what's the formula to find the volume of a cuboid? Length times breadth times height. So this formula is very important because if you forget this formula, then you can't do any questions on volume. Alright, so if I have the volume of a cube, which is 64 cm cube, then what is one side of the cube? Then you have to find the cubic root of 64. So you have to use your calculator, alright, and there's a calculator function, alright, there's a button in the calculator that can help you to find the cubic root of 64, which is 4 cm. So it means that every side of the cube is 4 cm, right? So this is 4, 4, and 4. And that's how you get the volume of a cube, 4 times 4 times 4. Alright, what happens if it's a paper one? You don't have a calculator. Then how do we get the length of one side of the cube? Then you will need to do some guess and check. So what times what times what is equal to 64? Right? So you have to think of a same number. So what number multiplied by the same number and that will give you 64? Is it 2 times 2 times 2? 3 times 3 times 3? Is 4 times 4 times 4. So if it's a paper one question, then you will have to do some guess and check. Alright, you have to think of a number. Alright, if the number doesn't work, then go to the next number. Alright, how about 216? What's the cubic root, or what is one side of the cube if the volume is 216 cm cube? So what is the one side of the cube? Again, take your calculator, key in the button, and you will get 6 cm. So one side of the cube is 6 cm. So which means that how do you find the volume of one cube? Length times height. And that's how you get the volume. Okay, the volume. So that is how you also get the one side of the cube. So how do you get one side of the cube? You have to find the cubic root of the volume. For example, if the volume of a cube is 8 cm cube, right, 8 cm cube, then what is one side of the cube? Then you will have to do some guess and check. If it's a paper one, what times what times what is equal to 8? So it has to be 2 times 2 times 2. So one side of the cube is 2 cm. Okay? Alright, then let's go a bit faster now. So if the volume of a cube is 125 cm cube, then what is one side of the cube? Then you must do some guess and check. Alright, if there's no calculator. So what times what times what? Alright, what times what times what will give you 125. So you have to do some try and error. Is it 3 times 3 times 3? Or is it 4 times 4 times 4? Is 5 times 5 times 5. So one side of the cube is 5 cm. Alright, so these are very special numbers. All the numbers that you see, you can realize that you can actually find the cubic root of all these numbers. For example, what is the cubic root of 27? That will be 3 times 3 times 3. And that will give you 27. So one side of the cube is 3 cm. How about if the volume is 1000 cm cube? Then what is one side of the cube? 10 times 10 times 10. Alright, that will give you one side of the cube, which is 10 cm. And then how about 729? Right, so you find the cubic root of 729, and that will give you 9, because 9 times 9 times 9 will give you 729. So that is how you find one side of the cube, which is very important, because in volume questions you may need to find one side of the cube. And then how do you find the cubic root of 512? So if the volume of the cube is 512, then what is the length of one side? That will be 8 times 8 times 8. Okay, so let me double check. 8 times 8 times 8, and you will get 512. So one side of the cube is 8 cm. And finally, the last one, what's the cubic root of 343? So then you do some guess and check. 7 times 7, is it 7 times 7 times 7? Alright, let's see. Yes, so 7 times 7 times 7, and you will get the volume of the cube. So one side of the cube is 7 cm. Alright, so in this part of the lesson, what are we doing? We are trying to find how to find one side of the cube. But before we can find one side of the cube, we must know how to find the volume of a cube. So to find the volume of a cube, how do you find? You have to find length. You must know the length, the breadth, or the length again, because it's a cube, so all the sides are equal. You call it length times length, and the height. So the volume of a cube is length times height. And if it's a cuboid, what is a cuboid? A cuboid is a rectangular block. So a cube and a cuboid, they are different. A cube is a square block. A cuboid is a rectangular block. And the length is the longer side, the breadth is the shorter side, and the height. So how do you find the volume of this cuboid? Length times breadth times height. Alright, okay, let's quickly move on to the next lesson, which is what we talked about just now. So you can see that how do you find the volume of the cuboid, which is length times breadth times height. Alright, so let's go down, and you can see that you have rectangular blocks. So to find the volume, what I would like to do is I will always write down the word volume. Volume of this cuboid is equal to 8 times 4 times 5. Alright, now you don't need to write the centimeter in your steps. Your final answer, you will need to write down the unit sign. But in your steps, you can leave out the centimeter, so that you don't have a lot of centimeters in every numbers. Alright, so 8 times 4 times 5, that will be how many? 160. So the volume, so your final answer, you will need to indicate the unit sign. So the volume of the cuboid is 160 cm cube. Okay? And then how about the next one? And by the way, the length is the longer side, the breadth is the shorter side, and the height will be how tall. How high is the cuboid? Alright, how about the next one? So volume of the cuboid is equal to length times breadth times height. So where's the length? The length is the longer side over here. So every time you have the word length, that is the longer side, and the breadth is the shorter side, and the height will be how tall, or how high. How tall is the cuboid? Alright, and then what do you get? You will get 72. So the volume of this cuboid is 72 cm cube. So you have to memorize. Okay, you have to memorize the important formula here. Alright, this is important because in all volume problems, you will definitely be asked to find volume. Okay, let's go on to the next one. Okay, and now you are going to find the height of the cuboids. So how do you find the height of the cuboid? Alright, now again another formula to remember. So to find the height, you have to know the volume of the cuboid, and then divided by length times breadth, or you call it area. Length times breadth is also called area, but because it's a cuboid, so what kind of area is that? The base area. What do you mean by base area? It is the bottom area. For example, the base area is what you see over here. So the base area is what you see at the bottom. That is called area, the base area. Okay? Alright, now, and one more thing to take note, whatever height that you want to find, alright, the volume must refer to whatever that you want to find. Alright, for example, if you want to find the height of the cuboid, then the volume must also refer to the same cuboid. If you want to find the height of the water, then the volume must also refer to the same thing. So a very important lesson here is the height and the volume must both refer to the same thing. Alright, usually students make mistake because they get confused. Right, the height and their volume, they don't refer to the same thing, and that's when they have mistakes. So when you want to find the height of the water, then you have to make sure you know the volume of the water. If you want to find the height of the container, then you have to make sure you have that, or you know what is the volume of the container. So the height and the volume must both refer to the same thing. Okay, so now let's look at the figures. So if the volume of the cuboid is 5,400 cm cube, then how do we find the height? So the height of the cuboid is equal to the volume of the cuboid as well. So remember, the height of what you are finding must refer to the same as what the volume, right? The volume of whatever, right? If you want to find the height of the cuboid, then the volume, you must know the volume of the cuboid as well. Okay, so what is the height? Height is equal to volume divided by length times breadth, or you call it the base area. So you have 25 cm times 18 cm. Alright, you don't need to write all the unit sign there. Alright, otherwise it will be very troublesome to have so many unit sign. So what I will do is, you can leave out the unit sign and just write the numbers. So for example, how do you find the height? Height is equal to volume, which is 5,400, divided by length times breadth. Okay, so how do you do this? Now, you have to multiply the length times breadth. So you have 5,400, and then 25 times 18, and you will get 450, and then you do your dividing. So 5,400, and you divide by 450, and you will get 12 cm. So the height of the cuboid is 12 cm. Okay, so important concept here, a very important concept here is, when you want to find the height of whatever, or the height of the cuboid, then the volume must refer to the same thing. Okay, the height and the volume, right? The height and the volume must refer to the same thing that you are finding. Okay, so let's look at another example. So how do you find the height of this cuboid? So again, you remember your formula, which is height is equal to the volume of the cuboid, which is 240 cm cube, and divided by length times breadth, which is the length is the longer side, which is the bigger number, and 5 times 4. Okay, 5 times 4. So once again, let me leave out the unit sign so that we are consistent, right? If you are going to leave out the unit sign, make sure you write all in numbers. You don't make sure you don't have any unit sign, right? If you want to write in numbers only, then you have to be consistent in what you are doing. So 240 divided by 20, and you will get 12 cm. So what's the height of the cuboid? The height of the cuboid is 12 cm. Alright? Okay, let's go on to another example, another part of the lesson. Okay, so what have we learned so far? We have learned how to find the volume of a cube, which is length times height, and we have also learned how to find the volume of a cuboid, which is length times breadth times height. We also learned how to find the height of a cuboid, which is height is equal to volume divided by length times breadth. Alright, now we have to learn how to convert cm cube into liters. Alright, so how do we convert cm cube to liters? Alright, now first of all, before we start on this part of the lesson, you have to understand that 1 liter is 1,000 milliliters, which is what you learn in primary 3. And 1 liter, right, can also be equal to 1,000 cm cube. This is what you learn in primary 5. Alright, primary 3, you learn 1 liter is 1,000 ml. Primary 5, 1 liter is now 1,000 cm cube. And not only that, 1 ml is also the same as 1 cm cube. Okay, so this is what you need to remember. So for example, if I have 300 cm cube, then how many milliliters? That will also be 300 milliliters. So you have to learn how to convert. Okay, now let's look at number 1. So how do we change into liters? Now this is a small unit. This is a big unit, right? Cm cube is small, right? It's a smaller unit compared to liters, which is a big unit. So from small to big, do you multiply or do you divide? What do you mean by multiply or divide? Like 1 liter is 1,000 cm cube. So if you are changing from small to big, then what must you do? You have to divide by 1,000. So from small to big, you have to divide. Okay, so this is a simple lesson here. if you want to change cm cube to liters, you have to divide by 1000. And how to divide by 1000? You can change the whole number into a decimal, right? Then you shift the decimal point to the left 3 times because there are 3 zeros. So divide by also shift to the left 1 time, 2, and 3. So your decimal point is now above the arrowhead and the 0 is in front. So how many liters is that? That will be 0.250 or 0.25 liters. Okay, that's how you change from small to big. Alright, another example, 470 cm cube to liters. You have to divide by 1000. Alright, so change the whole number into a decimal and then shift the decimal point to the left. So every time you want to divide, you have to shift the decimal point to the left 3 times. 1, 2, and 3. Now why 3 times? Because 1000 has 3 zeros. So now the decimal point is above the arrowhead and the 0 is in front of the decimal point. So how many liters is 470 cm cube? That will be 0.47 liters. Okay, let's do a bit faster now. How about 1870 cm cube? So small to big. So small to big, you have to divide and change the whole number into a decimal. Shift the decimal point to the left 3 times. 1, 2, and 3. And how do you shift to the left? You shift after 3 digits. Alright? So, okay, let me show you how to shift after 3 digits. Like, you put your pencil at the decimal point, shift after 1 digit. Alright, that's 1 time. After another digit, that is a second time, and then third time. So now your decimal point is above the arrowhead. So how many liters is that? That will be 1.870 or 1.87 liters. Alright, how about 6500 cm cube? How many liters is that? Well, if you're very good already, you can just change into a decimal and then just shift the decimal point to the left 3 times. 1, 2, and 3. And that is your decimal point. So 6.500 or 6.5 liters. There is no need to put the zeros behind because it's not necessary. Okay, you can just put 6.5 liters. Alright, now how about changing centimeter cube to liters and milliliters? Okay, now not very hard as well. You can change the cm cube into ml. Alright, how many ml is that? That will be 1800 ml. And if 1 liter is 1000 ml, remember 1 liter is 1000 ml, so you break up, right? 1 liter is 1000, and then when you take out 1000 ml, you will have 800 ml left. So 1 liter and 800 ml. Okay, how about 1200 cm cube? You what do? You change it to ml first. Alright, you can change it to milliliters, which is 1200 ml, and number bonds, take out 1000 ml, which is 1 liter, and after you take out 1000, you will have 200 ml left. So 1 liter and 200 ml. Alright, the next one, again, change it to ml. 4870 cm cube is also 4870 ml. And number bonds, so break up, you can take out 4000 ml, which is 4 liters. And when you take out 4 liters, that will be 870 ml left. So you have 4 liters and 870 ml. Okay, and the last one. So you can change it to ml. And if you're very good already, you don't need to show the number bonds. Alright, if you're good, then you can just put down the answer immediately. That will be 2 liters, right? 2 liters and 350 ml. Okay, let's go to how do we change liters into centimeter cube from big to small. So you can see that this time big, the liters is a big unit sign, and centimeter cube is a bit smaller. So from big to small, you have to multiply. Alright, earlier on, from small to big, you have to divide. But now, from big to small, you have to multiply. So how do you multiply? Okay, now, you take 4.85 liters and you multiply by 1000. Why? Because 1 liter is 1000 ml. Okay? Alright, so you have to remember all the important the conversion. Like 1 liter, you have to remember is 1000 ml. Very important. You have to remember all this. And then 1 liter is also the same as 1000 cm cube. Alright, and 1 ml is also the same as 1 cm cube. So this is very important again. So you have to make sure you remember this. Alright, so how many cm cube is 4.85 liters? Then you have to shift the decimal point to the right 3 times. So you have 1 to the right. When you multiply, you have to shift to the right. And then 2 and 3. So where is the 0 in the basket? Alright, the 0 is not in the basket, and the decimal point is above the arrowhead. And then, of course, you have a 0.0, 4850.0. So how many cm cube is that? 4850.0, but there's no need to write down the 0. Okay, one more example. Now, 9.67 liters multiplied by 1000, so you have to shift the decimal point to the right. Means after one digit, after the second digit, and then one more time. So there's a basket there, right? You can see a basket. So you put the 0 in the basket, and the decimal point is above the arrowhead, and then 0.0. So how many cm cube is that? 9,760 cm cube. Okay? Alright, let's look at a few more examples. So 0.535 liters is how many cm cube? So you shift the decimal point to the right 3 times. 1, 2, and 3. Okay? So what do you put on the arrowhead? Which is the decimal point and 0. So you have 535.0. So you just have to write 535. No need to write the 0 because it's the same. Alright, and the last one, 2.08 liters, and you multiply by 1000. So just remember, from big to small, you have to multiply. Multiply by how many? You look at 1 liter, which is 1000 cm cube. So you have to multiply and shift the decimal point to the right by 3 times. So you have to shift to the right 3 times. 1, 2, and 3. Okay, and you can see there's a basket there, empty basket. So put a 0 there, and the arrowhead, put a decimal point, and finish it by putting another 0. So 2080.0. So how many cm cube is that? 2080. Okay, once again, no need to put down the 0. Got it? Alright, let's quickly go to the next part of the lesson. Okay, now we come to word problems, which is the main part of the which is your paper 2, right? Usually paper 2 will have problems which are a bit more challenging, but let's look at a simple one, right? A simple problem that can also be found in paper 1, right? In paper 1, you will have simple word problems on volume. So the figure shows a rectangular tank, which is a cuboid. So every time you see a rectangular tank, then you are looking at a cuboid, and this cuboid contains water. So find the capacity. What is capacity? It means the volume. Can you find the volume of the tank? And your answer has to be in cm cube. Alright, so how do we find the volume of the tank? Alright, so then you have to recall your formula. And it's important that you must know your formula. If you cannot remember, then it's going to be very hard to even start the question. So volume of the container will be length times breadth times height of the container. So remember, the volume that you want to find must refer to the same thing as the height of whatever that you're finding. For example, if you want to find the volume of the container, then the height must be the height of the container. Because if you're not careful, you may put down the height of the water, which is wrong already. You want to find the volume of the container, then you must look at the correct height, which is the height of the water. The height of the container, right? You have to look at the height of the container. So what is the length? The length is the longer side, the breadth is the shorter side, and you times the height of the container. So you can use your calculator, alright? So of course, if it's a paper 1, then you have to do your working. So 22 times 20 times 20 again. So the volume of the container is 8,800 cm cube, alright? And you need to leave your answer in cm cube, right? Okay, so let's put down A and S, part A, 8,800 cm cube. That is the capacity of the container. Alright, how do you find the volume of the water in liters? Alright, to find the volume of the water, then you need to go back to your formula again. Volume is equal to length times breadth times height. And if you are finding the volume of the water, make sure that the height is referring to the water as well. Alright, so the volume and the height must refer to the same thing. Alright, so what's the length? The length will be 22 times 20 times the height of the water, which is 12 cm. And then you can work out. So 22 times 20 times 12, and you will get 5,280 cm cube. Okay, but how do you change to liters? This is this is cm cube, right? Cm cube. So to change into liters, you have to divide, all right, from small to big. Remember, small to big, what do? You have to divide. Divide by how many? 1000. So you can either use your calculator to just divide by 1000, or you change the number, the whole number, into a decimal point, and then you shift to the left 3 times, because when you divide, you have to shift to the left. And how many times must you shift? 3 times, because there are 3 zeros when you divide by 1000. So what do you put above the arrowhead? Which is decimal point. So how many liters will that be? 5.28 liters. So it is not necessary to put a 0 there. Alright, remember, you can leave out the 0. So what is the volume of the water in the container? Which is 5.28 liters. And that's how you solve part B. So a very simple problem, right, that can be found in your paper 1. Okay, let's go to the next one. Alright, now you can see the figure shows a rectangular tank again, which is a cuboid, and it contains 990 meter cube. Now, the meter cube is a lot of water. It's like swimming pool, right? Swimming pool meter cube. But if it's cm cube, is actually not a lot of water. So when you have cm cube and you have meter cube, which one has a greater volume? The meter cube has a greater volume, okay? Because meter is 100 cm. All right. So that's a bigger number than cm cube. Okay, so what is the height of the water in the tank? So how do we find the height of the water in the tank? So remember your formula. To find the heights of anything, you must know the volume divided by length times breadth. Alright, your second formula. Alright, so to know the height, so just have to remember the height and the volume must both refer to the same thing. So if I want to find the height of the water, okay, the height of the water level, right? So I must know the volume of the water. So what's the volume of the water? Which is 990 meter cube. Then can I find the height? Yes, I can. So the height will be equal to the volume of the water. So let's leave out the unit sign, which is 990 divided by length times breadth. So length is 10, breadth is 9. So remember, height and volume must always refer to the same thing. So this is a very common mistake that students will make. They get confused by how they find the volume or how they find the height, because they forgot that the height and the volume must always point to the same thing. So what is the height of the water? So you divide. So you have 990 divided by 90. So the height of the water is 11 cm. So you got your part A, which is a very simple answer, right? Not very hard to get. So what is the volume of the water needed to completely fill the tank, So you can see that if you look at the diagram, it is not totally filled, right? So you can pour some more water to fill up the tank. So is there a shortcut to do this? Yeah, there is. Because if you don't use a shortcut, or if you don't know the shortcut, then what you will do is you will find the volume of the whole container, which is length times breadth times the height of the container, and then after that you minus the volume of the water that's already inside, and that will give you how much more you can pour in, which is a bit longer. Alright, so when you have longer steps or more steps, there will be, of course, more chances to make more mistakes, right? So is there a faster way to get the how much more water needed? Yes, you can. You look at the height of the empty space. Alright, how much more water can you fill? What is the height of this water that you can fill up the tank? So you can see that this is 14, the height is 14, and you minus the height of the water that's already inside, and you can fill another, or you can top up another 3 cm height of water. Alright, so you can top up another 3 centimeter of water, which is the height of the water that you can pour in. So what is the height of this, or what is the volume of this water that you can pour inside? So you have to go back to your formula, which is length times breadth times height. So what is your length times breadth? Which is 10 times 9. And what is the height? Now remember, you can see there are a few heights here. There's a height of the container. There's also the height of the water already inside. And there's also the height of how much more water you can pour in. So which height are you going to use? Now, you look at the volume that you're finding, right? You're finding the volume of how much more water you can pour in. So you will need to look at this one, right? Because the height and the volume must always refer to the same thing. So the volume of how much more water is equal to length times breadth times the height of how much more water you can pour in. So that will give you 270 cm cube of water that you can pour inside. So your answer will be 270 cm cube. Now in some schools, because you're finding water, so water is measured in liters or ml. So some schools may want you to write in ml or liters. Then you have to write down 270 ml because liters and ml refer to liquids. All right, measuring liquids. Cm cube refers to the how much space a solid can occupy. All right, so cm cube refers to what? The amount of space something occupies. All right, how much space an object occupies. But liters and ml refers to the liquid, right? How much liquid is there inside the container. Okay, so that's how you find the height of the water in the tank and also the water needed to fill up the tank. So a very simple word problem again, but it's because of these simple word problems which you need to understand. And then when you understand how to do these simple word problems, then you can do the harder questions later on. Okay, now let's go to the last part of the lesson. Now, a rectangular tank, which is a cuboid again, measuring 30 by 20 by 60, was 2/3 filled with water. So now you have a fraction inside. Sometimes you may have a percentage in the problem. So what do I do if I see a fraction inside? Then this is what I usually like to do. I would like to put the fraction into the diagram. So the water is 2/3, and if there's a 2/3, there must be a 1/3, and the 1/3 is the empty space. Alright, and there must be one whole, which is the whole container. So there's a family of fractions. Alright, so every time you have a fraction, then there'll be 1/3 and 3/3. There has to be a whole number somewhere, right? So after some more water was added, what happened? Now the water level rose by 5 cm. So we can do some drawing. So for the harder problems, you will see me do some drawing onto the diagram so that it becomes more clear. So I'm going to pour some more water inside, and then the water level will rise by 5 cm. So you can see that the water level has now risen. Alright, you can see the dotted line. So the red color water is the water that you pour in, right? You pour inside. Okay? Alright, so what was the water in the tank at first? So can you find the water in the tank at first before you pour in, right? Before you pour in. Okay, so what do we do? Okay, now, so if you look carefully, where was the water at first before you pour in? It is at the blue color level. Right, this is the water at first before you pour some more water, right? And that is your 2/3, right? Your 2/3, right? 2/3 of water inside at first. Okay, now, so what was the water in the tank at first? Which is the question mark. Okay. So if you look carefully, now, what can you find or what can you do? Now, you can see that if you look carefully, you can find the volume of the container, right? So every time you're not sure how to do, right? If you're stuck in knowing where to start and how to start, all right, how to start your steps, and you don't know how to begin your steps, you look at the picture and you think about, is there any volume I can find? If you look carefully, I can find the volume of the whole container because I have the length, the breadth, and also the height of the container. So I can actually find the volume of the whole container. So volume is equal to length times breadth times height. And what's the volume? So 30 times 20 times 60, you will get 36,000, right, cm cube. And isn't that your 3/3? Right, 3/3. So it means that your one whole is the whole container. One whole represents the volume of the whole container, which is 36,000 cm cube. So you can find 1/3, you divide by 3, that will be 12,000 cm cube. Right? So how much water was there at first, which is your 2/3? And 12,000 times 2, that will give you 24,000 cm cube of water at first. So, so your part A, you have found your part A. And again, because it is water, right? You're talking about water. So you may want to change the cm cube into ml or into liters. So I divide by 1000 and I will get 24 liters. So there is 24 liters of water in the tank at first. Alright, so what was the water added to the tank? So if you look at the red color water, right, the red color water is the water that you added into the tank. So how do you find how much more water do you add inside? To find how much more water do you add inside, which is the volume, right, then that will be equal to length times breadth times height. So you may want to write out the formula so that you know what to do next. So if you are finding the volume of the red color water, which is the water added, then your height must also refer to the same thing, which is 5 cm, right? Your height, you have to refer to the same thing, right? So the volume of how much more water you can, or how much water is added, that will be equal to length times breadth times height. And what do you get? So 30 times 20 times 5. And so you have added another 3000 cm cube of water, and your answer has to be in liters. So you divide by 1000 and you will get 3 liters. So you have added 3 liters of water into the tank, right? And that's how you solve. All right, it's not a very hard problem. But what's the important lesson here? Now the important lesson here is the volume and the height must refer to the same thing. That's the important lesson. And also, if you see a fraction, then usually what I will do is I will put the fraction inside the diagram, because once you have more things inside the picture, then then it becomes more clear, and you may know how to write your steps. Alright, if your picture is too clean, there's nothing drawn on the picture, or you did not do anything on the picture, it's so clean, and then you will find that you have some difficulty trying to start, right, how to solve, right? There'll be some difficulty in trying to come up with the first step. Alright, so that is how you find volume. Alright, and it's a long lesson today. Alright, it's supposed to be a short lesson, but it became a long lesson. Okay, so we come to the end of this PSLE concept on volume. So it's an easy lesson. Alright, but even though it's an easy lesson, it's important because it will prepare you for questions that are harder. So to do the harder questions on volume, you will first need to know how to do all these simple questions, right? You will need to understand the simple concept on how to find volume of a cube, on how to find the volume of a cuboid, and also how to find the height, right? The height of water or the heights of whatever that's given to you. So all these are simple concepts that you must remember, and then once you are able to understand and remember, and then you can start to progress to doing the harder problems. And of course, there'll be more new things to learn when you solve the harder problems. These are just the basic, right? The basic and the basic understanding about volume. Alright, so we come to the end of this lesson, and so stay tuned for the next lesson, and we will be moving on to angles, right? So we'll be doing angles. There'll be 2 lessons on angles. So alright, so that's the end of our concept volume. Alright, so I'll see you in the next lesson.